So let's start with automation at the moment an event is occurring. Event-triggered automation. Going back to that typical workflow, we'll take a look at the first engineer response. These teams are typically overworked and they're understaffed. And a large percentage of these tickets are closed without any resolution. Oftentimes teams use a code like NTF for no trouble found, and this usually indicates that a problem is intermittent, can't be replicated. So the challenge is that the majority of these issues will resurface again and again until someone's able to capture the data in real time or replicate the problem. So with automation, the crime scene can be captured at the moment of the event. For example, by integrating NetBrain with a console like SolarWinds or a ticket system like ServiceNow, a problem area can be documented automatically in what we call a dynamic network map. And a predefined diagnosis can be initiated at that same instant. So, this might be at, say, 2 a.m. There's a bandwidth spike, or there's a failover event. Now, when the first engineer arrives on the scene, take Jerry here, they're picking up a ticket that is already enriched with the resulting diagnostic, the map of the problem area. So we believe that a human, in fact, shouldn't have to touch a ticket as that first line response, but instead automation should be the first response. Sometimes we call this tier 0 response, basically done by a bot instead of a human. So I'll welcome Chris Lopez to show us what this event-triggered automation looks like with a live demo. Over to you, Chris.
Thanks, Jason. Hey, everyone. I'm Chris Lopez, and I'm going to be running a demo of event-triggered automation for you today. We've created an environment that closely mimics a production environment, as you can see with the headquarters and multiple branch offices. And I'm going to introduce the network event. See, we have a video server in our headquarters, and it's sending traffic to a client in one of our branch offices. And I'm going to pull up the view of the live server here. As you can see, here in the command prompt, traffic is being sent to the device. And on the right side, you can see that we're losing about 50 to 60% of our traffic at any one time, and we don't understand why. From here, we're going to begin our journey into NetBrain's just-in-time automation workflow. In our network monitor, we can see that an alert has been generated for a slow application. As you can see, this alert is very recent. On the right, you can see a column labeled incident number. And this is where the monitoring solution has actually created an incident ticket based on the alert that was generated. As I navigate into it, we'll be taken directly to our instance of our ticketing system, which in this case is ServiceNow. And you'll be able to see basic information such as the ticket number, who it's been assigned to, what time it was created. But in the section below, you'll be able to see where our monitoring solution has actually handed off information directly into NetBrain itself, based on information gathered from the alert. You're going to see 3 fields filled in: source IP, destination IP, and a NetBrain map URL. Now, the source IP and destination IP were entered by SolarWinds, which detected the alert based on NetFlow and CBQoS information relayed from the network devices. NetBrain is then using that information to create a critical path of the problem area and put a link back inside the ticket. And the value of this map link cannot be overstated. This is the machine providing diagnostic data to your engineers before they sit down to begin troubleshooting the issue. As I navigate to the map, we're going to see an application path of switches, routers, and firewalls between the server and its client. These are devices that we need to look at in order to solve this network issue, and this is information that might have taken your engineers a long time to figure out on their own with manual network operations and documentation. On the left, you're going to see a runbook with a couple of nodes executed here, and these represent the basic diagnosis of the network issue. This map, as you saw, was created at the moment of the network event, and so was this runbook. It was actually executed right when the dynamic map was created. It's important to emphasize that this could have happened in the middle of the night, when no one was available to respond to the issue and capture real-time data. So I'm going to start looking at the results of the runbook nodes. Here we can see NetBrain has pulled basic information from each of these devices using the following CLI commands. In fact, if I look at this panel below, I'll be able to see the live output of the CLI for each of these devices for each of these commands. The main value here is twofold. First, we've captured data at the moment of the event, which for intermittent issues is incredibly difficult to obtain. The second value here comes from scale. Here, NetBrain has executed 6 commands across 5 devices. But imagine if you needed to scale that up to 10 or 50 or 100, and how much time that translates into your engineers hopping between a bunch of device CLIs with a notepad performing a stare and compare. Next, I'm going to check out the results of the overall health monitor. Here we can see that the overall health monitor is looking for common indicators of performance issues such as input errors, output errors, CPU and memory utilization, and it's actually visualizing this for us directly on the dynamic map. I can see that in the context of physical health, I might have a problem up here around this link. I might need to investigate that a little bit further. And again, this enables us to get a closer look at specific parts of our network while still maintaining the map as interface functionality that makes NetBrain so powerful. The point here is that NetBrain's CLI automation is very accessible to network engineers, and that we're using the same information that they work with in a more targeted way.